So let's say that you have 7 books. So you have a pile of 7 books, and you have a bookshelf that only has room for 3 books. So the bookshelf with 3 positions. So the question is, how many different ways are there for you to place 3 books onto the bookshelf from 7 options of books to begin with? So how many ways are there to arrange 3 books from a total of 7 books?
Like 210, maybe?
Okay, 210. What the rest of you guys think?
Would it be 42?
42. Anybody else? So lock in your answer before we actually talk about it. Think about what you would do. Yeah.
Wait, so there's 7 books, but only like 3 spaces?
Yeah, exactly. So let's say that we number the books 1 through 7. And let's say that we want to find the total number of possibilities to arrange 3 books at a time. So let's say one possibility is that you have book 7, and then book 6, and then book 3. This ends up being one possibility. Another possibility might be you have book 2 in the first position on the shelf, and then book 5, and then book 3. This would be another possibility. So the question is, how many different possibilities are there?
It should be 210,
Yeah.
right?
Okay, so another vote for 210. Any other answers you guys are coming up with? Okay, so one of you guys are getting 210. How are you doing that?
By basically doing the factorial from 7 to 5, just going 7 times 6 times 5, as you lose one option per spot that you place a book into.
Okay, great. So anybody want to add to that? Yeah.
No, that's the same, that's just what I got.
Okay, great. So the answer should be 210, and let's talk about why. So if you're not sure where to start, you should start listing out example possibilities. So when you do that, you'll start seeing the structure of what each possibility actually ends up like. So each of these possibilities that ends up being counted has how many options, has how many actual objects in it, has how many actual numbers in it. So there's 3. So that tells you the number of placeholders or number of categories in each of your possibilities. So this is very helpful because it tells you that there are 3 placeholders here. And for the first placeholder, indicating the first position on the bookshelf, how many options of bookshelf are there? Yeah, you have the full 7 options of books, for which you select 1 book. And then in the second placeholder, which indicates the second position on the bookshelf, how many options for books are there?
6.
Yeah, 6. And the last one is going to be 5. And then by the rule of counting, you simply multiply these 3 numbers together, and we're getting 210. So technically, this is different from a factorial, because in a factorial, you notice we start with a number and you multiply all the way down until you get to 1. But you notice in this example, we didn't go all the way down to 1, so technically this isn't a factorial. This is, so we're going to name this a new type of operation. We're going to name this a permutation. So a factorial only has 1 argument, because we know we're going all the way down to 1, so the only argument we need is what the starting number is in the factorial. So a factorial only needs 1 argument. But in a permutation, because we can stop at any point, we need 2 arguments. We need to know where to start and where to stop. So in this example, we're starting with the biggest number, which is 7, so that'll be our first argument. And the second argument, it turns out, is the total number of numbers. So here, what's the total number of numbers here?
3.
It's 3. So this means the second argument is going to be 3. So 7 permutation 3 means that you're going to start with the number 7, and you're going to count down 1 at a time until you have a total of 3 numbers. So that tells you that the ending number must be 5, because you only have a total of 3 numbers that you're counting down for. Any questions so far? So, this 7 permutation 3 is abbreviated as 7P3. And you have an option in your calculator to do this. So, you wanna enter in the first number 7, and then the operation of permutation, and usually it's abbreviated as NPR, not the radio station. But it's N is the first argument, and then P for permutation, and R for the second argument. And usually there's a button on your calculator that says NPR for permutation. And then the third argument is gonna be, or the third key that you process is gonna be the second number. So usually this operation, this permutation operation, is located around the same area that you found the factorial operation on the calculator. So go ahead and find this, hit 7 permutation 3, and make sure that you're getting 210. And if you need help finding it, let me know. Anybody need help finding it? Okay, in the previous example, we had 7 total books, and we were cycling 3 books at a time and ordering the 3 books, and we came out to 7P3. By the way, this P we said was short for permutation. This is the noun form, permutation, but you can also hear it as the verb form. People also say permute. So 7 permutation 3 or 7 permute 3, same thing.